And then hopefully this does not die on me.
Okay.
Because today's solving is a little bit harder than what we did yesterday. And because the video got messed up yesterday, then of course, you know, that won't be posted. Not that anyone's looking at that. Okay, so we are solving, but it is an option, like if you're absent or something like that, then you can catch up. We are solving equations. And maybe I'll get a little bit on here from what we missed. So we need to remember, as we're solving equations, to do exactly the same thing to both sides. We are undoing the operations. So today we're just going to add, besides simplifying to this, we're going to add to it that you need to get the variable to one side also. Usually, you're going to do this by adding or subtracting it. There are rare exceptions, but usually you're going to add or subtract it to the other side. And you're going to want to do this after you've simplified. So, let's say we have something like 2x plus 1 equals 5 parentheses x minus 2. Draw your wall. Now I noticed as you were working on the board yesterday, we do some, it might have been things that Mrs. Christensen taught you. It's not technically wrong, it's just really hard for me to read. So I want you to pay attention how I'm showing my work so that we're kind of all agreeing. If you do something different, as long as mathematically correct, it's not wrong, I'll understand what you're doing better if you do it the way I'm showing you. So we're going to distribute. I just draw these arrows so that you get in the habit of remembering, because often we forget this other thing. We write the 2x, but then we just copy down the plus 1 when it should be a plus 2. So I want to copy that. We copy down our equal sign and we distribute the 5 as well. Okay, notice 5 times 2 is 10, but it's minus, right? Now, notice I have a variable on both sides. I have it here, the 5x, and I have the 2x on there. Now I can either subtract 5x from both sides, or I could subtract 2x from both sides. It does not matter. I'll subtract the 2x. Do you see how I wrote that? I lined up my like terms. I simplified first, and now I'm getting my variable to one side. 2x minus 2x is 0. They undo. That leaves plus 2. If this were a minus 2, I'd copy down the minus, so I don't need the plus. That's assumed. And 5 minus 2 is 3x. Now I add my 10. And of course I'm down at the bottom here, so now I don't have room to show the work the way I'd like you to see it. Alright, what would be my last step here? Divide by, this is how you show it. With that little division thing, and it goes across the whole thing. So our answer is, just continuing, this would normally be like below there, 4 equals x. Now when we do inequalities, we're just going to get in this habit. If the variable ends up on the right, we're just going to flip the whole thing around. So we get x equals 4. Okay? That's going to be important for when we do inequalities. Let's do another example. Give you a second. I see some people still writing.
Wait, wow. Hold on. Okay.
Yes?
Why wouldn't you move the 2? Why wouldn't you divide the 2? Instead of...
Right here?
No.
Tell me which line it works. Second line?
No.
Third line?
No. Yes.
Right here. I'm solving for x. I need to get x alone. So I'm trying to undo everything around this. So first I undo the minus 10, and then I undo the times 3.
Why wouldn't you just divide 2 divided by 2?
Divided by 10? Because the operation here is not multiplication. This operation is subtraction. To undo subtraction, we add. So like addition and subtraction are inverses, multiplication and division are inverses. So these two undo each other, these two undo each other. And you're going to have other ones by the end of the year. You have square root and squares. Those undo each other. So you're going to have multiple options. But again, and just to make this point, please excuse my dear Aunt Sue. When we're simplifying, we go this way. Yeah, Sally. I don't know why everyone likes Sally so much. Sue is by far better. But anyways, when we're simplifying, we go that way, right? When we're solving, we go this way. We undo in reverse order. Okay, so let's get a couple more examples down. So let's say I have 3n minus 3 plus 2n equals 2 parentheses n plus 3. Walk me through it, Meredith. What would you do first? Besides draw your wall, what would you do first?
I would do the 3n plus 2n.
Okay, so do you notice how these are on the same side? I combine the things that are on the same side, so I get 5n minus 3. I'm not going to try to combine this end that's over on the other side with this end that's over here. Not yet. I simplified. There's something else we could do, Meredith.
Then you distribute the 2 and you get 2n, and then plus 6.
Yes. Okay, now what are we going to do?
You would plus 3.
We could do plus 3. What you just said is not wrong. I like to get my variable to one side first. So we're going to deal with this 5n or this 2n. What are you going to do? Minus 5n. Not the way I would have gone, but it's okay. It's alright. So what do we get right here? Negative 3n. And we're going to copy down the rest. See, this is negative 3, so we copy that down. Now what would you do?
Minus 6. And you would get negative 9.
Divide by negative 3.
And would equal positive 3.
Yep. Up. Flip it around. Better. Okay, just take that little extra step. I'm going to put 4 examples on the board, and I want you to do them in your notes, and then I'm slowly going to solve them, check them on your own as you get them done.
You're so late.
Yeah, I know. No one likes me.
True.
Alright, so I have that one up, and I'll write the others really slowly.
Are you going? Which way is it?
Doesn't matter.
Okay.
Maybe to slow myself down, I'll draw someone's portrait.
Cole's a moose.
Yay.
Moose?
Wow.
What?
Something new.
Wait.
Wait, what?
You're drawing you, donut.
Oh! Screw you.
Hey.
That's
That is no.
He's had a really bad day.
Oh, that's perfect.
I woke up
It's
like
got that signal for calm and sneer. Now, if you ever want
that was like a normal comment every day. And
It
on,
looks
the,
like
on the bus.
Yeah, I was
What
actually
do you think of widow's peak?
On the bus.
I was actually just thinking, add glasses, and this is actually, you're a mini cane.
Comment. Lift your hair up. Why? Okay, yeah, you have a
That forehead though. Oh
I
my
was
lord.
confused, like, why you
Hey, can I work on this?
No.
What class are you in right now?
City Hall.
Yeah, that's fine. Just don't be distracting to, oh gosh.
I'm distracted.
Trey's already there. He's like, what's that? Metal and gears, Trey. All right, let's wrap this one up.
There's some plastic on there.
Oh, build your wall. We built that wall so we have a clear distinction on both sides. Trey, you got these done?
I do it. Don't do it. Yeah.
Yes.
Okay. Have to do another.
I forgot about the one.
Come on, Barbara.
Here we go.
Oh, someone
Is
has
that a
a
barber?
Terrible. That is some killer essence right there. What is that?
Feels like
Is that a top stitch?
Man, that's supposed to be a stitch.
No.
It looks like one.
Why doesn't she have eyelashes?
What is that?
It does look like a mustache. It does.
Oh, she has a butt chin.
No, she doesn't.
I mean, in the picture she does.
No, she doesn't. It's art.
So future classes, when they go to look at our videos, they'll be like, these are portraits of previous students.
They'll be able to identify them.
They'll be able to steal your identities.
Kane, you should be
Yeah.
these sketch artists.
Hey, yeah, bro. Great. That's probably American never gets anything done.
You make more money than you now.
That wouldn't take much. Probably work at McDonald's, and,
You're dedicated.
especially when the $15 per hour thing goes through. Yeah, I'm
Ooh.
with. Go flip me some burgers.
Heck, I ain't going to college at $15. McDonald's. I'm Bojangles.
And then they'll fire me because
Taco
they figure out that they don't need me to flip burgers when they can get a robot to do it that Coleman built. Coleman will put me out of
They ain't
business
gonna get no burgers.
with his burger patty flipper.
Technology is one thing. Now,
And it'll be like cruel because I will have taught him robotics. And now
Then
it's
now-
my job.
now
because
you-
I was becoming an engineer.
now you've given him a reason to
to succeed. Yeah. I guess
I'll
I
make you forward.
He had no drive.
I'll work for Chick-fil-A. Yeah.
Yeah.
There we go. Okay. Anyways.
You want to work on it?
Any questions on any of these four? I realize some of you might not have got done, but with as far as you got,
I have a question on all of them.
yes.
What side are you supposed to move it to? 'Cause, like, I thought you were supposed to have, like,
3x equals like 4 or something, I don't know, like, but you always do it like, it's on the same side, that was supposed to be between the walls.
Okay, so first of all, did you get the same answers?
No, I didn't get any of this.
Okay, so which one do you want me to go through?
The negative one.
The negative
There's
one.
2.
I'm gonna draw a same thing.
Any of them.
Okay, I'll go through the first one.
Oh my.
All right, so we build our wall. I'll look at this side, nothing to simplify. I'll look at this side, nothing to simplify. But I do have x's over here and x's over here. So I need to get them to one side. It does not matter which side I get them to. I either add or subtract them to get it. Now, this is a plus 5 if it's not written, and this is a plus 2 if it's not written. So to undo plus, I subtract. So let's say I subtracted 5x, which is different than what I did. I bring down the negative 4. And 2 minus 5 is negative 3. And then I bring down my plus 5. And now I'm just solving on the other side. So I subtract 5 to undo the plus. I get negative. I don't really need to write that in equal sign. So negative 4 minus 5 is negative 9. Now I divide by negative 3. And I get x equals 3. And I just flip that around so that my variable's on the left.
Do you have to flip it around?
You don't have to, but we want to get that habit for the next chapter. Any other questions on these? Okay. Then, let's do some geometry applications.
Yay.
What?
Geometry applications.
We're doing shapes.
Okay, so the first geometry application. We need to remember this fact about angles. Vertical angles are equal. And I know what you're thinking. What in the world is a vertical angle? Well, a vertical angle are across from each other, like directly across. So, if I draw this is a pretty complicated diagram, but then I'll give you a simple one.
You're the best at drawing graphs, if you didn't notice.
Thank you. So I have a lot of vertical angles here. Let me mark a pair. See where this little green dot is? This angle that is with? It's vertical to this angle with that green dot. They're across from each other. You see they're kind of like diagonal? Let me do another one. Here's another example of vertical angles. So you see where I put this happy little star? Those are vertical angles. See, they're across from each other. But I also have another pair of vertical angles.
Was this the thing I was really bad at?
See where this sad face is?
Yeah.
Across from the sad face is another sad face. Those are vertical angles. Okay? So if this is 30 degrees, then what's this one? 30 degrees. And if this is 150 degrees, this one's 150 degrees.
I'm not bad at this game.
If this is 90 degrees, then this one is
90 degrees.
Yes. So, in our little application here, let's say this is 2x, and let's say this is 12. I would say, well, these are across from each other, so 2x equals 12. Divide by 2, x is 6. Okay?
Yeah.
Let's do a harder example.
Yeah.
This is 6x plus 3, and this is 8x minus 21. What do we know about these two? Well, they're across from each other, so they're equal. So I'd write 6x plus 3 equals 8x minus 21. Now let's solve that one. What do you want to do first? Rachel.
Bring the 6 over to the 8.
So we'll subtract the 6x. Because this is a plus if it's not written. So what do I write on the left?
13.
This is a 3. So 3. And then 2x minus 21. Now what do we do? Reagan.
You Not plus 21.
Add the 21. So we get 24 equals 2x. Now what do we do? Taylor.
Divide 2x.
Yep, divide by 2. So our final answer is 12. Now what if I wanted to know how much this angle is? X is 12, but how big is this angle? I take this 12 and put it in. And I'd get 6 times 12 plus 3, which is not going to make sense or something.
72 equals 3.
Oh, that's not too bad. 75. That's good. All right. The next thing is for honors. So honors is going to copy this down while the rest of you do something else. So the something else for everyone else. I want you to go to page 98. And on a piece of paper, I want you to do numbers 2 to 16 even. Yes. All right, honors. I want you to work on that quietly so that honors can continue their work. So we have talked about matrices. So we can have matrices that are equal. So let's say I put 2x here, y plus 5 here. Maybe I put a 2c plus 5 there. Maybe right here I put a 3w. And over here I put a whole other thing. Now this is a 2 by 2. So maybe I'll put a 10 here. Maybe a 9w plus 12. Maybe right here, c plus 8. Maybe right here, 5y minus 6. It's right here. Okay, so now I have a matrix, and I want to solve for all these variables. Well, this is in the same spot as this. So I'd say 2x equals 10. I'd solve that x equals 5. These are in the same spot. So I'd say 5y equals, or y plus 5 equals 5y minus 6. I might start by subtracting my y. Oh, that's minus 6. Then I would add my 6, and then divide by 4. So there's that y. Now if I wanted to know what these numbers actually are, I would take this and put it in. Right? Do I need to show you how to do that, or good? Good?
Yeah.
Okay. Same thing here. And I think you're probably getting the point. Like, yeah, I just set these equal to each other and solve. So subtract the c. Subtract the 5. C is 3. So this is 11. Make sense? Okay. And finally the w. So 3w would equal 9w plus... And my work here is really terrible. Like all over the place. Like when you're doing it, make it a lot more orderly. And just for a second, everyone look up. Let's say I'm solving this one. I need the variable on one side. Sometimes students do this and they get themselves all confused. And this is not wrong. What's 3 minus 3?
0.
I can have a 0 on the left. And then I'll get a 12 plus, or that should be a 12. Well, what am I going to do? Well, I subtract that other 12 over. And then I divide by 12. So it does look weird, but it still works. So you can get a 0 on one side. That's all right. Just get the rest. Let's practice one all together. So let's say I have 2w equals 5w plus 4. And let's just, to avoid that, I would subtract the 5. And then I don't even have that situation. Let's say I don't see that, and I'm like this. What's 2 minus 2?
0.
That's okay. Now what?
And you subtract the 0.
No, I need to get w alone. I need to get w alone. Do not look where the variable isn't. There's no variable here. The variable's over here. I need to undo this stuff. So I subtract the 4. So we get negative 4 equals 3w. Now what do we do? Divide by 3. Okay, so we get negative 4 thirds. It's okay to leave it like that. All right. Now everyone is on this page doing those numbers.